right, for this model, we're going to be looking at sort of a enlarged cross-section of a long bone. So you can see this here would be our long bone, and we can see this is going to be the tibia actually, and you can see up here in this proximal epiphysis that we have this compact bone on the outside with the spongy bone on the inside. Here's the diaphysis, epiphysis, metaphysis, diaphysis, and here we can see that this is going to be part of the diaphysis, and we have this hollow marrow cavity in here. So this area right here, so where we have the compact bone on the outside, and it's lined with just a tiny bit of spongy bone, that's what we're looking at here. So this is like going to be a slice through the diaphysis of the bone. And so this is going to be one side. It's covered on the outside here by periosteum, and then we have this compact bone here, and then the tiny little bit of spongy bone in here. So it would be like this small area of the bone right here. So this would be more superficial. This would be deeper. The outside of the bone would be here. This is the periosteum. This would be the medullary cavity or the marrow cavity on this side. So we can start from the outside. This here would be the periosteum. The periosteum has a couple of layers. It's got a fibrous layer, which we can see here, and then a cellular layer, which you can't really see very well in this model because the cellular layer is very small. But it would be on the very inside here of this fibrous layer. The fibrous layer is made of dense, irregular connective tissue. All right, and it's going to cover the outside of the bone, and it's a really important sort of attachment point for ligaments and tendons, as well as blood vessels. The periosteum is then going to be attached to the underlying bone by these what's called perforating fibers or Sharpie's fibers. So these guys coming here into the bone, they're going to perforate the bone, and they're going to attach the periosteum into this compact bone. So these are Sharpie's fibers here. So we said the inside cellular layer of this periosteum consists of osteoprogenitor cells, osteoblasts, and osteoclast. But we can't really see those individual cells on this model. In this picture here, it's just showing the periosteum kind of pulled away so that we can see how the Sharpie's fibers are attaching it. We can turn here, and we can see that normally the periosteum would be sitting, and it would be very closely adhered and closely opposed to our bone. All right, so as we look at the bone here, I'm going to actually flip it up so we can see the top. So this is the periosteum, and this is going to be the outer edge. And all of these areas are going to be layers of bone. Remember that our osteocytes, or osteoblasts, before they become osteocytes, are going to be laying down lots and lots of the bone matrix. And so these sort of layers of bone are called lamellae. So these lamellae are going to be on the outside of the bone, and they're going to run all the way around the shaft of the bone, all the way around the diaphysis. So these here are going to be called the external, right there on the outside, external, circumferential. They go all the way around the circumference of the bone, lamellae. So these are the external circumferential lamellae. And so we can see that they're all the way over here. Next, we have these sort of circular areas here. So these two that are jumping out at you are going to be these sort of circular areas. So they have a middle area here called the central canal, and that's going to be where our blood vessels and our nerves and our lymphatics run through. And then we have these concentric circles, or these concentric layers of bone. And these are called the concentric lamellae. And these layers of bone are going to be laid down so that their collagen fibers alternate. So we can kind of see here that there are some little grooves in these layers of bones. And this is trying to tell us the direction that the collagen fibers are going. So in this layer of bone, the collagen fibers are going in this direction. In this layer of bone, they're kind of going in a 90 degree, the opposite direction, 90 degrees to that. And they keep alternating. And so in this way, the different layers of bone have collagen fibers that run in different directions. And it's the same with these external circumferential lamellae. So we can see that the collagen fibers are going in different directions so that the bone is strong in many directions. We don't have all of the collagen fibers going in the same direction, because if that happened, then we'd be able to kind of shear the bone in between those collagen fibers. But now we have collagen fibers that go in all different directions. All right, so as I said, these out here are the external circumferential lamellae. these here that are going in these circles around our central canal, this whole thing is called an osteon. That's like the whole thing. But each of these little layers of bone is going to be a concentric lamellae that makes up the osteon. And so here's another example of an osteon with concentric lamellae. And then if we can see here, imagine trying to stack things that are round. There's always going to be spaces in between these round areas. So we can see, like over here, there's a little space. Over here, there's this triangular space. Over here, there's a little space. And so all of these spaces these are called the interstitial lamellae. They're kind of like unfinished osteons. They're partially resorbed. They're not a complete circle, and they're just sort of filling the spaces in between the other osteons. Those are interstitial lamellae. So each of these, they're different little tiny layers of bones that are the interstitial lamellae. Now if we move down through here, we can see on the inside of the bone, remember this is the marrow cavity over here. So on the inside of the bone, we have these layers that are going all the way around the internal circumference of the marrow cavity. And so these are called the internal circumferential lamellae. The internal circumferential lamellae. So there's lots of different layers of bones, and the layers of bones are called lamellae. Remember that. So next, we move to the inside here. Now, this is going to be the part where we have starting to get some of the trabeculae of spongy bones. So we can see that these are starting to be the trabeculae of spongy bone. So there's little like points that come out. And within the trabeculae of spongy bone, they're made up of what's called parallel lamellae. And the spongy bone is going to be covered, and the marrow cavity is going to be lined with this covering on the inside called the endosteum. So the endosteum is kind of an incomplete cellular covering that's made up of osteoprogenitor cells, osteoclast, and osteoblast. And it's going to be lining the inside of the marrow cavity. So this part over here is the endosteum, sort of these blue areas that are covering up the trabeculae of the spongy bone. So the trabeculae would be this bone-colored area over here. So some other features that we're going to see is that, remember, bone has a blood supply. Bone is very well supplied with blood. It's always remodeling. And so the blood is actually going to come in from the outside of the bone, and where it enters, we're going to call that the nutrient foramen. And I remember that because the blood is bringing nutrients into the bone, and foramen means a hole or opening into the bone, so the nutrient foramen. And then these here, we're going to have some channels throughout the bone. These right now we can see are filled with blood vessels, but on the other side we can see what they would look like if they were empty. So here, the channels, these openings for the blood vessels that go straight up and down here, and they would open into the middle of the osteons are called central canals. So these are central canals. And these would be filled with the blood vessels that would eventually go into the middle part of each osteon. So these are the central canals. But these central canals obviously need to connect, right? And they need to communicate with each other. And so they're going to connect through these little sort of horizontal canals called perforating canals. And these are the perforating canals. So we can see on the other side too. So these vertical lines are going to be the central canals, and they are connected by these horizontal or closer to horizontal or oblique lines called the perforating canals. Other things that we can see on this model would be here. We can see these little guys, they look a little bit like bugs or spiders, but these are actually going to be the osteocytes. So these dark guys here are the cells, and they have these little tiny little arm projections coming out, and they're actually going to be putting those little projections out and communicating with the other osteocytes. And they're able to do this and stretch these little projections out because there are tiny little openings in the bone matrix called canaliculi. And these canaliculi are going to allow these osteocytes to communicate with each other. And we will be able to see them better on the next model that we'll look at. So these are all going to be the osteocytes. On this side of the model here, we can see there's little openings here. So these are hollow openings. These are called the lacunae, and these lacunae are where the osteocytes would normally be. So in this case, they're empty, the little holes here that are called lacunae, and these are the sort of the holes or the spaces, the houses that the osteocytes live in. I think that's it for this model.